All right, taking a look at chapter 5, teamer number 2. Particle moves along a straight line. So when we say particle, we just say you're driving a car or you're walking north and south. From 0 to 5, the velocity of the particle is given by this function, and the position of the particle is given by s of t. And it is known that s of 0 is 10. So a lot of information there. Our initial position is 10. We're going to need that, I'm sure. And we've got a velocity. We could go ahead and graph that. So A says find all values in the intervals 2 to 4 for which the speed of the particle is 2. So I'm going to look at my graph. My graph looks like this. And from 2, I think 2 is somewhere around here, to 4. Where is the speed of the particle 2? So what we need to remember about speed is equal to the absolute value of velocity. So I need to know when is this function equal to 2. So it can actually be equal to 2 or negative 2 if that's the case. And I believe it happens to be equal to 2 here. And I think that is 3.128. But then it's also equal to 2 negative 2 right here, which the speed at negative 2 is 3.473. So this one would work 2 points. 1 point for both answers, and then 1 point for considering the absolute value. So if you just put the 3.18, you really got 0 out of 2. All right, part 2 says write an expression involving an integral that gives the position s of t. So the position is s of t, and its velocity is that function, and its position starts at 10. So I would describe this as you're walking somewhere with a velocity and you started 10 miles away from home and you kept walking. How far are you after so much time? So s of t should equal the integral from 0 to t of v of t plus 10. And that, I think, right there would be the integral, or 10 plus that, whatever. And then I would just use my calculator and calculate the area from 0 to 5. Should look something like that. I think that ends up being like negative 19.2. So it's negative 19.207 plus 10. So the answer is s of 5 is negative 9.207. And this again was worth 1 point here and then 1 point here. Looking for the next one. Find all times t in the interval from 0 to 4 for which the particle changes direction. So I had that graphed up there, but I can graph it again. So this is the velocity. Where does it change direction? So I think a lot of us did very well on this problem. It's going to change velocity, or it's going to change direction when its velocity goes from negative to positive, or when its velocity goes from positive to negative. And don't forget about the whole justify your answers. So I believe this value is 0.536, and this value is 3.317. So that's where it changes direction. And the other part of that is, the velocity here is 0. That's where it changes direction. So v of t equals 0. And then you say v of t changes from negative to positive at 0.536. V of t changes from positive to negative at 3.317. So it changes direction. There we go. And this is the required justification. You've got to say something about it changing from positive to negative. And then finally, is the speed of the particle increasing or decreasing at a time t equals 4? So I've got my velocity graph again. Here's t equals 4 somewhere over here. So my velocity there is something like negative 11.475. So I had a lot of people write that velocity is negative, therefore the speed is decreasing. The velocity is decreasing. That would be correct. But what is happening to the speed of the particle, remember? Speed is absolute value of velocity. So is that velocity actually decreasing? Picture reflecting this graph as an absolute value. This would become positive here, and then this would actually become positive here. If you picture the reflection, what is actually happening here? That speed is actually going up. So a couple of things you can write here. The thing to consider if you don't have a graph is, what is the derivative of speed doing at that time? And you could plug that in your calculator. You can just calculate the derivative of that function at 4, and you get negative 22.296. And you can say because velocity and acceleration are both negative, meaning their signs match, speed is increasing. And I think you can, with an explanation, I think you can probably understand that one.